Hey everybody, hope you're doing well. This video is going to walk you through section 2 of unit 10, which will teach you how to solve things dealing with permutations and combinations. This is going to build off of what you learned in the last lesson regarding the fundamental counting principle. These are just a couple other ways in how you count and arrange things. So we're going to talk about the concept of permutation first, go through a couple of things with that, and then we'll talk about the combinations piece. You'll notice again that on the screen I've got my graphing calculator up. You are going to need that just because there's a couple things that we can enter into the calculator that's going to make your solving a lot faster than having to use formulas. I will show you how to use the formulas if you don't have the calculator handy, but most of you should have your graphing calculator still. Have it for this video. It'll really save you some time. So let's talk about permutations. Definition of permutation, you can see at the top of the screen. It's from a group of items that occurs when no item is used more than once and the order of arrangement makes a difference. So in short, order matters. If I want to find a permutation of something, that means the order of whatever I'm trying to select from makes a difference. The biggest thing I would say, just to make this a little bit easier to think of, is if you need to rank things. So like first, second, third, fourth, fifth out of like a group of 10, 20, 30, 40 things or people or whatever, that's where permutations come in handy, where the order of how you select from the group makes a difference. So we'll see a couple of examples of that. But along the way here, we're going to be using a couple of notations here that are certainly new, but again, our calculators here will help sum things up pretty quickly here. Let's first talk about what's called factorial notation. So a factorial in math is basically a way to say, if I want to multiply from a certain integer all the way down to 1, it's used a lot in statistics and with, again, these counting concepts. So you can see here on the screen, factorial notation. If you look at the example, if I have something like 6 factorial, factorial is represented by an exclamation point. 6 factorial is the same as doing 6 times 5 times 4 times 3 times 2 times 1, which you solve that, you get 720. On a graphing calculator, here's how you find anything with a factorial. So if you were having to go find 6 factorial, you enter the 6, following the steps that I've written out. So you enter the number, you go to math, you then go to the prob menu, so for probability. The fourth option down is an exclamation point. So that's 6 factorial. Hit enter, boom, 720. It's a faster way than typing in 6 times 5 times 4 times 3, etc. Because obviously, if we start getting up into double digits, even if I wanted to go triple digits, which your calculator would have a lot of trouble processing, it's a much faster way to do that sort of math. And you'll see as we go through this here where that gets used. Other thing we're going to use with this, so we'll use it with both permutations and combinations formulas. If you're dealing with permutations, you can see the formula that is there. If you take a look at the way that it's written out, so you see this NPR. The N that's in front of the P, N represents the total amount of things you have in your group. Okay, so 20 people in a race, 20 would be the N value. If you have 50 people in the contest, 50 is the N. So whatever that total is. P stands for permutation. R stands for how many things you're pulling out of the group. So 20 people run a race. I want to know how many ways the first 7 people will finish. Okay, that 7 would be the R value. If I have 50 people in the contest and only 2 can win a prize, that 2 would be the R because that's how many selections I'm making. So we'll see that format here and we'll use it in a few places. If you have to do it by hand, that's the formula you would use. Okay, again, I'm going to use the calculator to shortcut a lot of that. And we'll go through and enter some stuff here in a minute with a couple of problems that are underneath. Again, with this formatting here, and you'll see with the combinations in a couple minutes, the N is always going to be the bigger number because N is the total amount in the group. So the amount that's in the group should be bigger than the amount of things that you're pulling from it. So that's just something to keep in mind when we write this down. So again, we'll take a look here at a couple examples. I'll show you how to enter some stuff here, and we'll be good to go. So number 1 says evaluate. Use your calculator to confirm the answers. So number 1 says solve 9 factorial. If I have 9 factorial, That would be the same as doing 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So again, if I'm doing it the long way, as you can see here on the screen, 3, 2, 1, you get 362,880. If I use my calculator, again, to do factorial, you hit the 9, math, scroll over the prob, option 4. There's your answer right there, 362,880. That's what 9 factorial represents. Okay, I'll write these answers down in here in a second, but again, just so I don't have to keep losing things off the screen over and over again, you can just follow it off the calculator portion on the right side. Second question has that permutation notation, 6p3. So what that basically means is you have a group of 6 items, I'm pulling 3 things out of it, and I want to know how many different ways that can be arranged. So the way that we enter this in, we're going to go right to the math menu and back to prob. Here you see NPR. Now you'll notice, again, if you have an 84, which I think most of you do, you should be able to enter in directly right next to the P on both sides. So all I have to do is, well, the 6 was on the left and the 3 was on the right. Hit enter. Comes up with 120. So there would be 120 different permutations of pulling 3 things out of a group of 6. Okay? You can use the formula, again, with the factorials and plug stuff in and do it the long way if you want to. But again, notice how pretty quick it was to find that answer. Same thing in number 3. You have 10p7. So group of 10, I'm pulling 7 things out of the group and want to know how many different ways I can arrange it. Again, that notation, go into math, prob, second option, enter the 10 on the left side, put the 7 on the right side. 604,800 ways you can pull 7 items out of a group of 10. Okay? So that's all you have to do to enter this in. It's very quick. It does that formula for you. It's a lot faster than having to work through the formula. But again, if you have to do it by hand, then so be it. So with those, we're going to take a look here. So again, you can see on the right side of the screen, that's your answers for 1, 2, and 3. Okay? I'm going to go ahead for 4 and 5 here. We'll do some flipping back and forth and writing stuff out here. So number 4 and 5, here's a couple of really common word problems you would see with permutations. So like I said, permutations, order matters. So for number 4, 25 people run a race. How many ways can people place first, second, and third? And we're going to assume here no ties. So this is a classic example of a permutation problem. The first thing you want to figure out is, well, how would you write this? So the way that you would write this, so again, you know it's a permutation because, again, order matters in this problem. The bigger number, so the 25 people that are in the race, goes on the left side of the P. On the right side, you'd put the 3. Okay, so because you're pulling, there's 3 places that you're looking for here. So you're looking for how many different ways those 3 people can place out of the 25 in the race. So 25p3 would be your notation. That all you would have to do is go back to your calculator. So again, math, prob. Whoop, I hit the wrong button. My apologies there. Let's clear that out. Math, prob. Make sure you scroll down to the second option before you hit enter. There you go. 25, 3 on the right. And there you go. Again, you can use the formula to confirm that, but look how much faster that was. 13,800 ways that you can have 3 people placed in those positions out of 25. Number 5 here, that will be another permutation problem because you're scheduling things, so order does matter when you schedule. How many ways can you schedule 6 classes from a list of 10 possible classes in your school day? So again, let's first figure out what would the notation be. Again, scheduling things, so that means order is going to matter when you put your classes in. Again, the bigger number always goes first. You have 10 possible options. You're choosing 6. So your notation would be 10p6. And then you're going to go ahead and enter this in your calculator. Math, prob, second option, 10 and 6. And you end up with 151,200 ways. So I'm going to quickly write out here, again, all of our different answers so you can feel free to jot this down. But that's, again, how we use permutation notation, how we use our calculator to figure out all of these different things. All right, so again, you can certainly use the formula if you'd like, but ultimately, the biggest thing you need to make sure of, especially if you have to do a word problem like this, which on your assignment, you're going to have to do one or two of these here, you need to know what makes a permutation and how to have the correct notation for it. So if you want to jot those down, just so you have it handy, hit the pause button here and go ahead. All right. I'm going to go ahead here, clear this out. We're going to go ahead to the last page. So one other thing I'm going to talk about here briefly is to find the permutations of duplicate items. So the first part was assuming no repeaters here. If we have some repeats, what do we do from there? So the way that we find the number of permutations of a group of items, if we have repeaters, is we have to divide away and factor out what repeats. So the notation that's up above is basically saying take the factorial of however many items are in the group, then divide away whatever the repeaters are. So I'm going to show you here two quick examples here with some words and figure out the different ways we can rearrange the letters. So let's talk about here number 6. We're going to use what's up above here to find a number of distinct ways to rearrange the letters in the words. Let's look at the my last name here, Aiello. How many different ways can I rearrange those letters? So first thing I want to do here is, how many letters do I have? Well, there are 6 letters in my last name. Okay, so up at the top, I'm going to have 6 factorial. Okay, so again, the top is the total. At the bottom, I'm going to put in the factorials of anything that repeats. So if I look at my last name, the only letter that repeats is the letter L. How many times does it repeat? Twice. That's what I put in my denominator. So in the bottom, we put the repeat. So we put the repeaters in the bottom, and in this case, it's the letter L. Okay? Now, if I had more things that repeated, I would put those things in my denominator as well. So you can't have more than one factorial underneath. Now, again, you can punch this in your calculator here, but just again, so I don't lose the screen here. So we have 6 factorial. So we did that from the other side. That's 720. 2 factorial is just 2 times 1, which is 2. You would divide those. There's 360 distinct ways to rearrange the letters of my last name. So let's look at another word here. Let's look at the word Pennsylvania. So there are 12 letters in Pennsylvania. So again, the 12 goes on top because that is the total. And underneath, I'm going to put the repeaters. So I see 3 N's. So that's going to go underneath. So again, the repeaters go underneath. So the letter N, there's 3 of them. I also see 2 A's. That's going to go underneath as well. Okay? Nothing else repeats. So we're done figuring that part out. Now all we have to do is put this in the calculator and solve. So again, 12 factorial using the steps from before. You get a gigantic number, which again, that happens when you use factorials, 479,001,600. In the bottom, 3 factorial times 2 factorial. So that would just be 3 times 2 times 1 times 2 times 1 is 12. All you have to do is just divide those two numbers. There are 39,916,800 distinct ways you can rearrange the letters in Pennsylvania, which is quite a lot. So that's how you find permutations of duplicate items. Basically, find the factorial of how many you have in the group, divide away the factorial of anything that repeats. That's how you're going to go about solving that type of problem. So you will see a question like that on your assignment. Last thing we're going to take a look at here is the other half of this concept here, combinations. So permutations, order matters. Combinations, order does not matter. So we'll see a couple problems here where order doesn't matter. Okay, the notation looks very similar. You'll notice the formula, if you compare the two, is a little different from the permutation formula because there's an extra factorial. Basically, that's going to decrease the number of these. There is a numeric difference between permutations and combinations in many, many cases. So that's kind of where the difference comes into play here. But the biggest thing with combination is that order doesn't matter. That's when we use the combination concept. Now, you'll notice here for combinations, you'll see the letter C. You saw as we were going through on the calculator, probably NCR. We're going to go ahead and use that. So we're going to go ahead here, use our calculator. We're going to evaluate 8 and 9, and then we'll talk about how to do 10 and 11. So let's go back to the calculator here. So number 8 has 11C5, so that's saying the combination of pulling 5 things out of a group of 11. So I'll go to math, prob, anything with that letter C, that's going to be option 3, NCR. So again, very similar. You just got to make sure you're matching whatever letter it's giving you. So all you got to do is type it in. If I'm trying to find a combination of 5 items out of a group of 11, there's 462 combinations. In number 9, you do the exact same thing. So again, go to math, then prob, then option 3, 14, C6. Pulling 6 items out of a group of 14, there's 3,003 combinations. Again, that's just, the main difference is ordering of things not mattering versus the order actually mattering. So let's take a look here at the 2 word problems just so you can see why order matters versus, in this case, where order does not. So problem for number 10. You want an island vacation that can bring 5 people with you. If you have 20 friends to pick from, how many different groups of 5 can you take? So the reason why we use combinations here is because we're not ranking your friends here, okay? It's just saying, hey, we need to take 5 friends. It doesn't matter what order you pick your friends in. You just have to pick 5 of them, okay? One person out of that group of 5 is not getting a better vacation or more perks. There's no qualifiers with that versus the other ones you pick. So this is why we're going to use combinations rather than permutations. So our formatting for this is very similar, except we use the C instead of P. There are 20 friends. You're picking 5. We are going to use combinations, so 20C5 is what you would type into the calculator. So again, we're going to go back out of it. So math, prob, 20 on the left, 5 on the right. 15,504 different combinations of friends you can pick to go on this island vacation. Again, just like the last page, I'll write this down here so you can jot it here in just a minute or follow along with the calculator screen. Last one here, number 11, student councils holding elections. Brad, Nick, Julietta, Taryn, and Darnell all decide to run for 2 open positions. How many ways can they be elected? So again, combinations used here because they're just running for 2 open spots. It's not that one spot is one role and one spot is another. It's not like somebody gets president and then the other person gets vice president. Order does not matter in this case. It's just that there's 2 open spaces. So that's why this would be an example of a combination problem rather than permutation. Our formatting for this, so even though you don't technically see 2 numbers in this problem, there's 5 people running. 5C2 would be your notation. Then all we got to do is just enter that into the calculator. So one more time, math prob option 3, 5C2. You get a small answer here. If you get a small answer, that doesn't necessarily mean it's wrong. When you have a small group and you're picking an even smaller subset, you're going to have limited combos to pull. So in this case, you would have 10 combinations. So I'm going to go ahead here, jot in these answers, and again, feel free to fill these in just so you have them handy. Now again, like I said before with the permutations, it's the same with combinations. If you want to do it by hand using the formula that I've given you, you are certainly more than welcome to. But again, if you've got the graphing calculator handy, use it. So that is your lesson there on permutations and combinations. There's a little Schoology quiz that goes with this, 8 questions, mostly fill in the blank. I think I have a couple multiple choice thrown in there that are really basic. Make sure, again, you take your time typing in your answers. Make sure you're accurate. You don't lose digits or anything, because it will mark it wrong. So do take your time with that. Otherwise, that's the last lesson of this entire school year. So hopefully, again, you've learned something here over these last few weeks. Again, I know this isn't your typical format on how you would probably learn Algebra 2, or probably the preferred way to do it, but I know that a lot of you have at least done a good job of keeping up with the work. I appreciate your efforts, and hopefully, again, you've retained some of this, you learned something with it, especially those of you that are taking math classes beyond this year. Those of you that aren't, congrats on at least finishing up what you've been required to do in high school. So, again, finish off your work here. If you owe me anything, keep in mind grades are due Wednesday, June 3rd. I have a deadline set at 12 o'clock that day, just so I have enough time to enter everything in, because my grades then have to be 100% finalized by Thursday the 4th. So if you owe me stuff, please make sure it gets done ASAP. Otherwise, those I's will turn into zeros, and your grade will be your grade. So if you have any questions on this stuff, as always, send me a message on Schoology, shoot me an email, stop by my office hours on Zoom. If you have questions about your grade, again, please get a hold of me here so we can talk that out. Otherwise, again, I greatly appreciate your efforts. Thank you for putting in the work that you did over the course of the entire school year, and especially the course of these last couple of months here. So have a great summer. Stay safe, stay healthy, and I look forward to seeing you all in the fall.